Hi, this video is to help you understand the proper way to graph all the getting to the core data, this getting to the core assignment. So this is, should have a data table with 400,000 years worth of climate data taken from a glacier. So that data is real. That shows the year before present and the carbon dioxide concentration in parts per million, and then the temperature anomaly. And that just means they're just saying if the current year has a temperature of 0, how do the previous years compare? It's something that I wish wasn't the case. I wish they just reported the temperatures in degrees Celsius. But anyway, this is often how it's done. It's reported in a difference between current temperature and previous temperature. So here's the way you're going to orient your graph. You should have received a piece of graph paper with a line drawn down the middle and orient it this way, landscape style. And this is important. There are plenty of ways to mess this up. In previous years, it was kind of fiasco-like. So what we're going to do is orient it that way. And on the bottom, you might not be able to see this very well. Let me see if I can zoom in a little bit. But on the bottom, follow the directions in the Vostok data instructions, Vostok data station instructions. You should see the bottom is going to be where you put your years before present, and that will number from 400,000 years before present up to 0, the present. And instruction number 2 tells you precisely how to do that. Start on the left side with 400,000. Every single square should represent 10,000 years. So I just mark mine off because I'm lazy. At every 5 blocks, I marked with another 50,000 years. So 350,000 years before present, 300,000 years before present. So the left side of the thing represents the past, and you're working your way toward the future as you go to the right. Okay, so once that is labeled, you're going to be making 2 graphs. One here in this space with carbon dioxide, one here with temperature concentration or temperature anomaly. So here's what that graph should look like. Not that one, but this one. There we go. So the first graph you'll make is the CO2 concentration. And I've actually written it. You can't see it because the scanner cut it off, but I wrote CO2 levels ppm right here. So that's what all these numbers represent. And the next instruction on that sheet of instructions says how to label this out. Start with 100 at the bottom and count by 25 parts per million and count your way up to 400 parts per million. Once you have this, you can go to the data table and plot your data. You'll just march across line by line by line, plotting the data, and you'll end up with a squiggly line, which probably goes up at the last instant before it gets to the present day. So once you're done with that, then you can go to the last step where you're going to graph your temperature. And same thing, the scanner cut this off, but I've written temperature anomaly in degrees Celsius over here on the far left side. And the instructions say to start with -10, count your way up by 1 degree Celsius until you get to +2. That's the expectation. And then when you have the graph ready to graph, you'll just plot the data points. Plot them exactly the same way using the same time scale down here, but plotting the temperature data up here. Ultimately, you should finish graphing today or come very, very close to finish graphing today. And then tomorrow you're going to compare the 2 graphs. So you're going to look for things they have in common and places that they differ. Got it? I hope so. Go be awesome.